Mechanics, Paper 4, February March 2025. So let's go into question number 1. Okay, three coplanar forces of magnitude 40, 30, and x act at a point in the direction shown in the diagram. Okay, given that the forces in equilibrium, find the value of theta and x. So since the question said the forces here are in equilibrium, so we can say that my fx is equivalent to 0 and my fy equivalent to 0. Okay, and usually we will define my right hand side direction as a positive direction. So if this is my positive direction, this direction will be positive direction, so my left hand side is going to be negative. Similarly, I will put upward as a positive direction, and so downward will be negative. Okay, and for 30 newton and 40 newton is already in term of the x and y direction, so we don't need to resolve that. But if you notice the x, it is in a angle below the x-axis with the theta. So we resolve this to the x. So will be x cos theta, and we resolve it into y, where it will be x sine theta. Okay. So now the question said it is, since the question said it is equilibrium, so fx equal to 0, so we can make it x cos theta minus 40 is equal to 0 because it is on negative direction. Therefore, x cos theta equal to 40. Similarly, it's going to be 30 minus x sine theta equal to 0. Therefore, x sine theta equal to 30. So I make this as equation 1 and this as equation 2. So in order to find the x and y, so what I do, I first thing I put it 1 square plus 2 square. Okay, so it's going to be x square cos square theta plus x square sine square theta is equivalent to 40 square plus 30 square. So x and x is the same term, so we can factorize the x square. So it's going to be sine square theta plus cos square theta is equivalent to 2500. Sine square plus cos square is equal to 1 using the trigonometry. If you still remember, sine square theta plus cos square theta equal to 1. Okay, so 1 times x square is remains as x square, 2500. Therefore, my x will be 50. Okay, and to find the theta, so what I do, I'll do equation number 2 divided with equation number 1. So will be x sine theta over x cos theta equivalent to 30 over 40. Therefore, x and x you can cancel. So it's going to be tangent theta equal to 3 over 4. Therefore, theta will be 36.9 degree. Okay, please make sure you put the degree symbol here, even though like in mechanics you don't need to put any units, but for theta you must put the degree symbol, otherwise it's considered as a radian. Okay, so this is the working. Question number 2. A cyclist travel along a straight road 4 meter per second. When she passes through O, she decelerates a constant rate. Okay. For this question, since it's a constant acceleration formula, so I will prefer, normally I will represent the information on diagram. So it will be easy, or it will be like a small guide for me when I solve the question. So I just draw a straight line. So let's say here is where the O, where when they start here is U equal to 4. And then she accelerates a constant rate at the distance of 42. So from, let's say here is your s equal to 42, 42, and here when they reach your speed, I just make it as a u also, as a v. Okay, it doesn't matter. And then she maintained the speed for 50 meter. Okay, so let's say from here to here, s equal to 50 meter, and they maintain the speed, so u equal to v, so your a equal to 0. Okay, and then she decelerate at 2 meter per second before coming to rest. So when say decelerates, so it's going to be a equal to -2, and the distance travel is 16. So s equal to 16. At this point, my final velocity is equal to 0. Okay, so find the value of v. So we have here three stages, and this form actually we don't have the t, we don't have the a. So here also is both is unknown, so we can't find anything. So I use a third stage. Okay, the first stage you need at least a in order to find the v. So we don't have the a, so we cannot find. Second stage, there's a constant speed, so we can't find the second stage. So now I use the third stage to find the v. So here I can use the constant acceleration formula, the SWOT formula. So I think I got the information of the initial velocity, which is u. I got the final velocity, which is v, a, and s. So I can use v square equivalent to u square plus 2as. So my v is equal to 0, my u equal to v square plus 2. Make sure your a here is acceleration and they say it's a decelerate. So your a is -2. Please take note on that. -2 and s equal to 16. Okay. Therefore, v square is going to be 420 64. Therefore, v equal to 8. Okay, find the total time for which she in the motion passes through. Okay, means they need to find the total time for her from here. Okay, from here all the way until here. So for this I'm going to use the help of the vt graph. For me, it maybe can help me because I don't know the information, so I can represent the graphical method. It's a bit helpful for me to understand the situation. So since they said u equal to 4, so I just draw the basic vt graph. It's going to be very perfect one. It's just a basic and simple one is fine. Okay. So since they said it begin with 4, so I just go until here, and then just nice as constant velocity here, and then they become rest. Okay. So here is 4, rest should be until here. Okay. And here is 8. So they said the distance is 42, so area under the graph for vt graph, so this is vt graph. So the area under the graph will be the distance, so it's going to be 42, 50, and 16. Okay, so and the time here maybe I just make it as a, from here to here is b, from here to here is c. Okay, so I just find the a first. So it's going to be area of trapezium. So 1 over 2 multiplied with 8 plus 4 multiplied with a equal to 42. So we simplify this, we'll get a is equivalent to 7. And then for second one is a rectangle. So will be 8 times b equal to 50. So b equivalent to 6.25. And for the third one will be triangle. So 1 over 2 multiplied with base times height will be 16. So 4, so c equal to 4. Therefore, total time will be 7 plus 6.25 plus 4 will be 17.25. That's it. Okay. So question number 3. An aeroplane is flying at a constant speed. The aeroplane is flying horizontally. The aeroplane engine produces a constant power of 5,500 kilowatt, and the aeroplane experiences a constant horizontal force of this 25 kilonewton. Find the speed. So for the power formula, you can directly use the power formula. So power here is actually P equal to FV, and the F we used here is actually 25 kilo. Okay. Therefore, 5,500 kilo is equivalent to 25 kilo times V. Therefore, V is going to be 220. That's it. For B, the aeroplane then ascend 300 meter in 50 seconds, while maintaining the speed of same speed. Okay, the resistance, the resistance force is no longer constant. Okay, so the work done against the resistance force in 300 meter is 270,000 kilojoule. The mass of the aeroplane is 60,000 kilogram. Find the average power. So here they ask for average power. So what we know, in order to find the work done by the engine is equivalent to average power times time. Okay, so the work done by the engine is going to be two things. Number one will be the change in potential energy, because they say it's ascending. Okay, it go up 300 meter in 50 seconds, and since they said maintaining the same speed, so there is no change in speed, so no kinetic energy. And number two will be the work done against the work done against the resistance force. So work done against force, okay, or resistance force, doesn't matter. Okay, we try find the change in potential energy. So change in potential energy will be mgh, where m is 60,000 times g is 10 and height is 300 meter. So you'll get 180,000 kilo. Okay, therefore work done will be, oh sorry, power will be, work done, total work done will be 180,000 kilo plus 270,000 kilo over time will be 50 seconds. Therefore it's going to be 9,000 kilo. Okay, so just take note, if there is a change in speed, then there will be a change in kinetic energy also. But since there is no change in speed, so we ignore the kinetic energy. Okay. Question number 4. Two particles A and B have a mass of zero point 0.3 and zero point 0.1 respectively. The particles are attached to the end of light inextensible string. The string passes through smooth pulley. The particle hang vertically below, and the pulley both particle initial height x, okay, ground, then release from the rest. Find the tension in the string and the acceleration of the particle. Okay, so since they release from the rest, okay, so this is the object is heavier than this object. So A is heavier than B. So A will go down and B will go up. Okay, and then since A is going down, so for A, the downward direction is positive and upward is negative. And for this, for B, upward is positive and downward is negative. Okay, so I from the here you can say here will be your weight mg and here will be T. Similarly, T mg. Okay, so for A system A, is going to be T minus 0.3 G equivalent to MA. So this for system A. Okay, so you can rearrange. So T plus what plus? Sorry, minus 0.3 A equivalent to 0.3 G. Okay, or 0.3 G equal to 3. G equal to 10. Okay, so this will be our equation number 1. And for second system, system B, since it's going upward, so it's going to be, it's, hey, I'm sorry. I think it should be other way around. I'm sorry. This is going down. A is going down. I'm very sorry. So it should be 0.3 G minus T equivalent to 0.38. Okay, so weight minus tension, I'm sorry. Therefore you can rearrange. It's going to be 0.3 A plus T equal to G equal to 10, so you can directly put 3 here, so will be equation 1. And for the second one, it's going up, so T minus mg equal to ma. Therefore it's going to be negative 0.1 a plus t equivalent to 1. So this is going to be our equation number 2. Okay, and then you can solve this simultaneous equation and find your a is equivalent to 5 and your t is equivalent to 1.5. Okay, during the subsequent motion, B does not reach the pulley. When A reaches the ground, it counts to the rest. Given that the greatest height of B above the ground is 1.2, find the value of X. Okay, so let's assume this is the initial position of B. Okay, this is the height distance from A is X. And then when when the A reach the ground, once the A reach ground, B will reach a certain height, which is also X. But you must take note that once the A reach the ground, B will continue to move upward because at this point the B still have a speed. Okay, the B still has a speed. So the B will continue to move up due to the inertia. Okay, due to the inertia, the B will continue to move up due to the inertia until the speed of the particle B becomes 0. So we assume here. Okay, so this is the greatest height, 1.2, and this I name it as S. Okay, for the S, they move up, they will move under gravity. Okay, free fall, something like that. Okay, first we try to find. So here my u is equal to 0, and here is another u, I don't know, and here my v equal to 0. So I find the u here first, the u1. Okay, so for that we can use the v square equal to u square plus 2as. Okay, so my v, since the object is going up, so I assume the upward direction is a positive direction, so my a here will be positive. So my v here will be v. So u square is equal to 0 plus 2, and my a is I took from here, my a is here 5, and s is x. They move x unit up. So my v square will be 10x. Okay, and for here, this point, my v equal to 0 and my u equal to cert 10x from here to here at this point and this point, from these 2 points. And my s will be, the total is 1.2 minus 2x, this value. So we put in, so v equal to 0 equal to u square will be 10x plus 2. And since the object is going upward, so here I put a as a negative 10. Or you want to consider as upwards a positive direction, so you can change this to the minus, it doesn't matter. And s equal to 1.2 minus 2x. Okay, so to solve this, so it's going to be 20 bracket 1.2 minus 2x equal to 10x. So 1.2 minus 2x equal to 1 over 2x. So 1.2 will be 2.5 over 2x, and my x will be 0.48. Okay, so that's all from me. Thank you.